Learn Compose. Description: the Sci-kit Learn Compose module provides tools for building more complex machine learning pipelines by combining different estimators. This module allows you to streamline the process of pre-processing data, selecting features, and building models. Inputs. Data: the input data can be a pandas data frame or a NumPy array. It should be in a suitable format for the specific estimator you are using. Target variable for supervised learning tasks. The target variable should be provided. It can be a single column from the data frame or a separate NumPy array. Outputs. Transformed data: the output will be the transformed data after applying the specified transformations and feature selections within the pipeline. Model: the final trained model is returned, enabling you to use it for predictions. Steps. Pre-processing: this involves steps like data cleaning, scaling, encoding categorical features, and handling missing values. The column transformer class is a versatile tool for applying different transformations to specific columns. Feature selection techniques like feature importance ranking, dimensionality reduction (PCA), ELDA, and feature engineering can be incorporated to improve model performance. Model training: the desired machine learning model, e.g., linear regression, random forest, support vector machine, is trained on the processed data. Metrics. Accuracy measures the percentage of correctly classified instances for classification problems. Precision indicates the proportion of correctly predicted positive instances among all positive predictions. Recall represents the proportion of correctly identified positive instances among all actual positive instances. F1 score: a balanced metric combining precision and recall. Mean squared error (MSE) evaluates the average squared difference between predicted and actual values for regression problems. Visualization plots. Feature importance plots show the importance of different features in the model. Confusion matrices visualize the performance of classification models. ROC curves plot the relationship between the true positive rate and false positive rate to assess model performance. Learning curves evaluate the model's performance as the training set size increases. Fine-tune parameters. Hyperparameter tuning: adjusting parameters within the chosen model to optimize its performance. E.g., using grid search CV or randomized search CV. Regularization parameters controlling the complexity of the model, e.g., lasso, ridge, elastic net. Uncertainty methods. Confidence intervals provide a range of values around a predicted output, indicating the uncertainty in the prediction. Bootstrap aggregation bagging: creating multiple models from different subsets of the data to estimate prediction variability. Challenges and fixes. Challenge 1: data leakage, introducing information from the target variable into the training data during pre-processing, leading to overly optimistic model evaluation. Sample use case that resulted in challenge 1: using a transformer that utilizes the target variable, e.g., scaling based on target values before splitting the data into training and testing sets. Fixes to challenge 1: apply the transformers after splitting the data into train and test sets. Ensure that any pre-processing steps only use information available during the training phase. Challenge 2: overfitting: the model performs exceptionally well on the training data but generalizes poorly to unseen data. Sample use case that resulted in challenge 2: using a complex model with too many parameters or not enough data for the model to learn from. Fixes to challenge 2: consider simpler models. Apply regularization techniques. Use cross-validation to evaluate model performance. Or gather more data. Challenge 3: data imbalance: uneven distribution of classes in the target variable can lead to Biased model predictions. Sample use case that resulted in challenge 3, a dataset where one class is significantly more frequent than other classes, e.g., fraud detection. Fixes to challenge 3 use oversampling techniques, e.g., smart undersampling techniques, or cost-sensitive learning to balance the classes. Challenge 4 handling categorical features. Categorical features may require encoding or one-hot encoding before being used by many models. Sample use case that resulted in challenge 4, a dataset with columns containing text labels or other categorical values. Fixes to challenge 4 use ordinal encoder or one-hot encoder within the column transformer to transform categorical features. Challenge 5 missing values. Handling missing data appropriately is essential for model accuracy. Sample use case that resulted in challenge 5, a dataset with missing values in some columns. Fixes to challenge 5 use simple imputer to fill missing values using strategies like mean, median, or most frequent value. You can also use KNN imputer to impute missing values based on similar data points. Challenge 6 feature scaling. Different scales of features can impact model training, leading to inaccurate results. Sample use case that resulted in challenge 6, a dataset with features having significantly different ranges, e.g., one feature in meters and another in millimeters. Fixes to challenge 6 use standard scaler or min-max scaler within the column transformer to scale features to a common range. sklearn compose column transformer. Description. Column transformer is a powerful tool in Sci-kit sklearn that enables you to apply different transformations to different subsets of your data, creating a pipeline that prepares your data for machine learning models. Inputs: data, a pandas data frame or a NumPy array containing your dataset. Transformers, a list of tuples, each containing the name of the transformer, the transformer object itself, and the columns to which it should be applied. Remaining features optional: a string specifying how to handle columns not explicitly included in the transformers. Drop drops them. Pass-through keeps them unchanged. And remainder applies another transformer to them. Outputs: transformed data, a NumPy array or pandas data frame containing your data after the specified transformations have been applied. Steps: transformer definition: define each transformer with its name, the object to be used for the transformation, e.g., one-hot encoder, standard scaler, etc., and the columns where it will be applied. Pipeline construction: combine the defined transformers into a column transformer object, specifying the remainder argument as needed. Data transformation: apply the column transformer to your data to perform the transformations. Metrics: not directly applicable to column transformer itself, as it's a pre-processing step. Metrics are used to evaluate the performance of the model you train after using column transformer. Visualization plots: not directly applicable to column transformer itself. Visualizations are typically used to understand the transformed data after it's been processed. Fine-tune parameters: transformers parameters: each transformer likely has its own parameters. Tune these parameters within the transformers themselves. Remainder argument: adjust remainder to control how columns not included in transformers are handled. Uncertainty methods: not directly applicable to column transformer itself. Uncertainty methods are usually associated with models, not pre-processing steps. Challenges and fixes. Challenge 1: handling categorical features. Sample use case: when working with categorical features, it's common to use one-hot encoder or similar techniques. If not properly implemented, this can lead to high dimensionality in the transformed data. Fixes. Carefully select the handle unknown parameter of one hot encoder. Ignore is often useful to handle unseen categories. Consider techniques like feature selection to reduce dimensionality if necessary. Challenge two different data types. Sample use case when dealing with mixed data types, e.g., numerical and categorical. You might need different transformers for each type. Fixes. Define separate transformers for each data type and apply them using column transformer. Use appropriate transformer objects for each type, e.g., one hot encoder for categorical, standard scalar for numerical. Challenge 3 transformer order. Sample use case. The order in which transformers are applied can impact the results. Fixes. Carefully determine the order of transformers based on the specific needs of your data and model. Consider using a pipeline if the order is crucial for the overall transformation sequence. Sklearn, Compose. Transformed Target Regressor. Description. The transformed target regressor is a method estimator that fits a transformer to the target variable, and then fits a regression estimator to the transformed target. This can be useful when the target variable has a nonlinear relationship with the features, or when the target variable has a distribution that is not well suited for linear regression. Inputs. Regressor. The regressor that will be fitted to the transformed target. This can be any regressor that implements the fit and predict methods. Transformer. The transformer that will be used to transform the target variable. This can be any transformer that implements the fit and transform methods. Outputs. Predictions. The predictions of the regressor on the transformed target. Transformed target. The transformed target variable. Steps. Fit the transformer to the target variable. Transform the target variable using the fitted transformer. Fit the regressor to the transformed target variable and the features. Predict the transformed target variable using the fitted regressor. Inverse transform the predicted transformed target variable to get the final predictions. Metrics. R-squared. The coefficient of determination, which measures the proportion of variance in the target variable that is explained by the model. Mean squared error, MSE. The average squared difference between the predictions and the actual values. Root mean squared error, RMSE. The square root of the MSE. Visualization plots. Scatter plot of the predicted vs actual values. Residual plot of the errors versus the predicted values. Distribution plot of the errors. Fine-tune parameters. Regressor parameter. The parameters of the regressor can be fine-tuned. Transformer parameter. The parameters of the transformer can be fine-tuned. Uncertainty methods. Confidence intervals. Confidence intervals can be calculated for the predictions. Prediction intervals. Prediction intervals can be calculated for the predictions. Challenges and fixes. Challenge 1. The target variable may not be transformed in a way that is suitable for the regressor. Sample use case that resulted in challenge 1. The target variable is a skewed distribution, and the transformer is a log transformation. The regressor is a linear regression model. Fixes to challenge 1. Try a different transformer, such as a Box-Cox transformation. Use a regressor that is more robust to nonlinearity, such as a support vector machine SVM. Challenge 2. The transformer may not be able to fit the target variable well. Sample use case that resulted in challenge 2. The target variable is a time series, and the transformer is a moving average filter. The time series has a trend that is not captured by the moving average filter. Fixes to challenge 2. Try a different transformer, such as a seasonal decomposition. Use a regressor that can handle time series data, such as an ARIMA model. Sklearn, Compose. Make column transformer. Description. a utility function that helps you build complex data transformation pipelines for machine learning models. It allows you to apply different transformations to different subsets of columns in your data. Inputs. Transformers, a list of tuples, each containing transformer, the transformation object you want to apply, e.g., a standard scalar, one hot encoder. Columns, a list of column names or indices to apply the transformer to. Remainder, one of drop, pass-through, or a transformer. Sparser threshold, sparsity threshold for the output of the transformer. N jobs, the number of jobs to run in parallel for the column transformer object. Outputs. Column transformer object, the fitted object that can be used to transform new data according to the specified transformations. Steps. Column selection. Make column transformer takes a list of tuples where each tuple specifies a transformation to apply to a subset of columns. Transformation application. When you fit the column transformer, it applies each specified transformation to the corresponding columns. Remainder handling. The remainder argument defines how to handle columns not explicitly included in the transformers. Metrics. Not directly applicable, as make column transformer is a preprocessing tool, not a model. You'd evaluate the performance of your model that utilizes the transformations from make column transformer. Visualization plots. Not directly applicable. You might visualize the transformed data using the column transformer output for exploration. Fine-tune parameters. Transformers carefully choose the appropriate transformations for each column subset, e.g., scaling numerical data, encoding categorical features. Remainder. Select drop to drop columns not in the transformers list. Pass-through leaves them unchanged. Sparser threshold. Set the threshold for sparse output applicable to certain transformers. N jobs. Adjust the number of parallel jobs based on your hardware resources. Uncertainty methods. Not directly applicable. Uncertainty measures are typically associated with model predictions, not data transformations. Challenges and fixes. Challenge 1. Incorrect column selection. Sample use case that resulted in challenge 1. You mistakenly apply a scalar to categorical features, leading to unexpected results. Fixes to challenge 1. Carefully examine your data and select the appropriate transformation for each column type. Challenge 2. Data leakage. Sample use case that resulted in challenge 2. You fit the column transformer on the entire dataset, including the target variable, potentially leading to data leakage. Fixes to challenge 2. Ensure you only fit the column transformer on your training data and use it to transform both training and testing data. Challenge 3. Overfitting. Sample use case that resulted in challenge 3. You select a complex transformation that overfits the training data, leading to poor performance on unseen data. Fixes to challenge 3. Select transformations that are appropriate for your data and avoid overly complex ones that might memorize training data patterns. Challenge 4. Memory issues. Sample use case that resulted in challenge 4. You are working with a large dataset, and the column transformer consumes too much memory. Fixes to challenge 4. Use techniques like data chunking to process the data in smaller batches or use alternative transformers that are memory efficient. sklearn, compose, make column selector. Description. The make column selector function from sklearn, compose is a convenient tool for selecting specific columns from a data frame for use in machine learning pipelines. It provides a flexible and expressive way to specify the desired columns based on different criteria, such as data types, patterns in column names, or custom functions. Inputs. Pattern a string or list of strings representing regular expressions to match column names. D-type a data type or list of data types to select columns based on their data type. Exclude a string, list of strings, callable, or a combination of these, specifying columns to exclude from the selection. D-type includes similar to D-type, but specifies data types to include instead of exclude. D-type excludes similar to D-type, but specifies data types to exclude instead of include. Regex a regular expression pattern to match column names. Match a string indicating whether to match the entire column name, all or any part of it, any. Regex exclude a regular expression pattern to exclude columns that match the pattern. Outputs. A callable that can be used to select the specified columns from a data frame. Steps. The function analyzes the provided arguments to determine the selection criteria. It constructs a callable that accepts a data frame as input and returns a list of column names that meet the specified criteria. Metrics. Not applicable. This function does not directly calculate any metrics. Visualization plots. Not applicable. This function does not generate visualizations. Fine-tune parameters. Pattern fine-tuning. The regular expression pattern can be used to target specific columns more precisely. D-type selecting the correct data types ensures that only relevant columns are included. Exclude specifying columns to exclude allows for removing unnecessary or problematic features. D-type include this parameter allows for selecting only specific data types, potentially simplifying the feature selection process. D-type exclude this parameter allows for excluding specific data types, which can be useful in scenarios where certain data types might lead to issues in the model. Regex fine-tuning. The regular expression pattern can be used to target specific columns more precisely. Match. This parameter allows for specifying whether the entire column name should match a regular expression or only a part of it. Regex exclude. This parameter allows for excluding columns that match a specific regular expression pattern. Uncertainty methods. Not applicable. This function does not involve uncertainty estimation. Challenges and fixes. Challenge 1. Specifying incorrect regular expressions can lead to unexpected column selection. Sample use case that resulted in challenge 1 using a regular expression that matches more columns than intended. Fixes to challenge 1. Carefully review the regular expression pattern to ensure it accurately matches the desired columns. Use online tools or resources to test and validate the regular expression. Challenge 2. Selecting columns based on data types might not always be sufficient, especially in datasets with mixed data types. Sample use case that resulted in challenge 2. A dataset containing features with both numeric and categorical data, but only numeric features are desired for a specific model. Fixes to challenge 2. Consider using additional selection criteria, such as column name patterns or custom functions, to refine the column selection process. Use exclude or D-type include parameters to further specify the desired columns.